Greeting and good day to our respective lecturer, Professor Dr. Andrew, and my fellow colleagues. So I'm Majid Anak Combs, my metric number 240302122, and today will present to you a critical evaluation of risk metric methodology as used by Sarawak Energy Solutions for a mid-sized energy services company in Bintulu, Sarawak. So today I will focus on the methodological weakness in hazard identification risk assessments and offer evidence-based improvement from recent literature. So here is our presentation outlined, and we have the introduction, company profile, hazard identifications, recommendation, weakness and recommendations, risk assessment with 3 weakness and 3 recommendation, conclusion and reference. So this become our roadmap, and we will first to understand the company, then critically examines how they identified hazards, and followed by 3 distinct problems in risk assessment. For each problems, I will propose a practical evidence-based solutions. The risk matrix in OS. Here we have the risk matrix or hierarchy widely used for simplicity. Evaluation focus on the methodological flaws in hazard identification and risk assessments, and this not included the terminology errors, classification, alternative methods such as bow tie or frame. In other words, the risk metric is popular because it's easy to use and visually ranks risks. However, my assignment was very specific. I cannot critique things like wrong hazards name or missing category. Instead, I must look at the process itself, how hazards are identified, and how likelihood and severity are justified. I also cannot propose alternatives and only improvements to the existing metric. So here we come to the company profile. Sarawak Energy Solution, or SES, is a Bintulu-based company located in the high-risk environment gas compression and turbine servicing. And so the nature of business is MRO of gas compressions and turbine systems. It have 240 staffs, and the nature of the activity going to service or either is schedule or emergency turbine servicing or shutdowns. So all the activities to be carried out, the tasks like servicing the turbo turbine inside the compressor house, where drop object, gas release, and fall from heights become the real threat for all the personnel involved within the vicinity. Right. Hazard identification weakness. The weakness with contextual deficiency in target populations segmentations. So number one, where hazard listed for all personnel involved, no roles distinctions. For example, drop objects, technicians, and work at height underneath, whereby work helpers perform their tasks. And the result, one size fit all control mislengthened conditions. So meaning that the risk assessment from groups everyone's together. For drop objects, they assume that the same control works for the technician working at height and the helper perform the job or standing underneath the platform. But the technician's main task is losing balance while tethering tools. The helper risk is being struck. By not separating the Sarawak Energy Solution may overlooks the needs of exclusion zones for helpers. The hazard identification recommendations is role-based hazard context matrix, is create roles time hazard interactions matrix, add descriptor who is most exposed and why, and this been proven by Casper and Alvent in 2025. The vulnerability different methods. So to fix this, Sarawak Energy Solution should add a simple column for each hazard, specific with rows and why. The cost almost nothing but enable tailor control. Double layer to the technicians, exclusive zones for helpers, and then the research confirmed that ignoring vulnerability difference in major flaws in traditional metrics. Risk assessment weakness one is about the likelihoods is qualitative anchoring bias. So number one is uncontrolled gas release was rated likelihood equal to 2 is either medium, low or medium based on assumptions of perfect lockout takeout or LOTO disciplines, not historical data. The evidence given by Alaceru and Castro et al. In 2024, severity affect underestimate rates catastrophes. Right. The assessor wrote depend entirely on the discipline of lockout takeout. If permit to work is weak, probability might be rise, but they still gave a low likelihood score because they assume perfect discipline. This is anchoring bias. They anchor on how things should be, not on real failure rate. Research shows that when consequences are severe, people tend to underestimate likelihood. Risk assessment recommendation number one, posing function for historical precedence. Before scoring likelihood for severity could be 4 or 5, and then ask, how many times has control failed in last 5 years? If 0 or unknown without proof, increase likelihood by 1 level up. So again, Casper and Abend, given the evidence, reduce optimism's bias. The solution is posing function. The mandatory question, if you cannot point to actual data showing that lockout takeout has never failed in 5 years, you must increase likelihood score. This forces assessor to confront reality instead of wishful thinking. Risk assessment weakness 2 is about severity. Completion of direct versus systemic consequences. Sleep rate severity equal to 2, either it's minor to moderate. Ignore systemic severity slips near edge or the machinery, whereby the severity rates could be 4 or 5. The evidence given by Mossman's 2024A ordinal scales cannot reflect harm amplifications. So in other words, the rate is slips on the floor as low severity, but the same slips if it happens next to a rotation turbine subs or an unguarded edge can lead to amputation or fall from height. The metric treats severity as a fixed property of the hazard, but it actually depends on context. This is dangerous oversimplification. Risk assessment recommendation 2. Two severity scoring rules. Step 1. Assign initial severity if severity 1 as 1. Step 2. Ask could this trigger a secondary event or higher severity. Number 3. Final severity equal to max severity 1 secondary severity. Evidence given by Casper and Urban 2025 score spreading logic. To fix these two pass rules, first score the direct injury, then ask if this happens, could it cause something worse? If yes, use the higher severity. This forces assessor to think about secondary accidents like slips that lead to fall into machinery. Risk assessment weakness number 3 is about multiplications. Invalid multiplications of ordinal scale. Sarawak Energy Solution multiplies ordinal score. Example 3 times 5 equal to 15. Number 2, ordinal scales do not support arithmetic ranks become arbitrary. Example, drop objects becomes the score will be 12 versus manual handlings also 12. The same score but expert ranking differ. Evidence given by CRISPR in 2021, Mossman's 2024A and B. Right. Multiplying numbers like 3 and 5 assume they are real numbers with equal interval. But likelihood 3 does not mean that 3 times more likely than likelihood 1. When two different hazards get the same product score, the assessor override the matrix with their own judgment, proving the multiplication is meaningless. Risk assessment recommendation number 3. Replace multiplications with decisions rule metric lookup table. Use predefined lookup tables according to ISO 31010 2019 style. Number 2, example, fall from height, likelihood might be 3 and severity might be 15. Critical manual handlings, likelihood 4 and severity 3 equal to high. No false equivalence of score. The evidence again given by Mossman in 2024A maintains simplicity without mathematical invalidity. So instead of multiplying, use a predefined lookup table. This is still a risk metric, but it works like a decision rules. Given likelihood y and severity, likelihood x and severity y, look up the risk bands. This respect the ordinary nature of the data and avoid the mathematical nonsense of multiplications, ISO 31010 actually recommends this approach. Summary of the recommendations. If we have a look to the table, is hazard identifications, contextual deficiency, rows, time by hazards, interaction metric. So the likelihood here will be the anchoring bias. So the recommendation, the weakness is anchoring bias. Recommendation posing function for historical precedents. And then severity, the weakness is direct versus systemic completions. And then recommendation two-pass severity scorings, and then multiplications, invalid arithmetics, that's the weakness, and our recommendation is rule-based lookup table. So to summarize, 4 methodological problems, 4 practical fixes, all are based on peer reviews, literature from 2020 to 2025. None require abandoning the risk matrix, only improving its internal logic. The conclusion here, the risk matrix is not inherently invalid, but Sarawak Energy Solutions apply it with all correctable methodological flaws. Hazard identification lacks role-based context, fixed by roles, time hazard matrix. Risk assessment suffer from anchoring bias in likelihood and fixed by posing functions with historical data. Computations of direct versus systemic severity with that been fixed by two-pass severity scorings. Invalid multiplications of ordinal score fixed by ISO 31010. Lookup table. All improvement retain simplicity while restoring methodological soundness. No need to abandon the risk matrix, only to change how it populated and calculated. So, in other words, in conclusion, the risk matrix is not inherently bad, but Sarawak Energy Solution apply it with severe correctable errors by segmenting rows, posing historical checks, using two-pass severity and replacing multiplications with a lookup table. The matrix become methodologically sound while retaining its simplicity. So here are the reference that I use for all the assignments and during the activity in progress. So with that, thank you very much. And again, I'm Majid Anak Ikom 2403022. Thanks a lot for your time and attention. So any comments, you can email me to the email address as shown on the screen, 2403122@siswa.unimas.my. Thank you very much again.